Then, if you didn't turn the page, you should have. You have odds in favor. And then odds against. Okay. Odds are similar to probabilities, but not quite the same. A little bit different. All right. So we need to talk about probabilities today. Okay. We've had long discussions in this in chapter when you're in 6th grade, when you're in 7th grade. So I'm just going to be hitting the highlights of it. I'm not going to focus in on that. If you need to get a refresher, go to my YouTube channel. There's probably 6 different lectures on probabilities, and so you can go back and, if you'll just do a search on the channel for probabilities, you'll get all the ones that are there. Last year's are there, and I've already talked about probabilities some in some of the other classes. So, but probabilities are simply this. Probabilities is basically a mathematical guess on whether something or not occurs. Okay? It's a mathematical guess on whether or not something occurs. Now, probabilities do not mean that it's going to happen or it's not going to happen. The probability is simply that. It's just a guess, realistically. Taking facts that you think you have, facts that you think you know, and then applying those facts to random choice or random picking something. Okay? For example, if I made if I made a brown bag, and this brown bag had green marbles in it, blue marbles in it, and red marbles in it. Now, obviously, as we look at that bag, if we could see the bag, the probability of you reaching in and pulling out a certain marble would be, it would be one out of one every time, because if you could see what you were reaching for, then you could pick out whatever they want the probability on. We're assuming that this is a bag that you can't see in, that all the marbles are the same size, they're the same texture, they could be, any of that stuff. Now, just looking at the bag, it's very obvious that there's more what? Red, blue, or green? Red, okay. So it's a higher probability that you're going to pull out red, okay? The lowest probability is whether you pulled out a green, okay? Now, we can figure the probabilities, okay? The formula for probabilities is simply this. The probability is the favorable outcomes over the total outcomes. Okay, it's the favorable outcomes over the total outcomes. So in that bag, we've got 1, 2, 3, 4, 5, 6, 7, 8 red marbles. I'm just going to put these over here. 8 red, 6 blue, and 4 green. Okay, so what I'm going to do is we're going to figure the probability of each one of those colors. Okay, so we're going to figure the probability that we reach in and pull out a red one. Okay, well, to do that, we've got to know the favorable outcomes. So the only favorable outcome I have is to reach in and pull out a red one. Okay, so how many possible red marbles could I pull out? There's 8 of them. I'm only going to reach in once, but I have 8 opportunities to pull out a red marble. So on top of our proportion, or our ratio, goes 8. How many total outcomes are there? How many total marbles are in the bag? 18. And so that's 8 over 18. Now I must simplify, which means obviously we're going to reduce it. It's going to reduce to 4 over 9. Because you got to divide by 2 to top and bottom. 4 doesn't go into 18. At least in my world. Okay? In my world, 4 doesn't go into 18. Now, maybe in hers it does, but not in my world. Really?
Oh my God.
All right, probability that you're going to pull out a blue. Well, go back to the picture, and we have 6 blue ones. Okay? So my top part of the fraction will be 6. My bottom part of the fraction is still the 18. So 6 over 18 will reduce to what?
3 over 9.
Which will reduce to what?
1 over 3.
1 over 3. We divide by 6 to top and bottom for those of us that aren't thinking.
Why not 3? Oh, because 3.
You can do 3, but then you'll have to do 2 after that. I just chose to do 1 step instead of 2 steps. Don't look like that, like you don't. You're over there going, I didn't do nothing. I'm just like, I didn't do anything.
What?
Huh? All right. Now, probability that we're going to pick a green marble is equal to 4 over 18, which is 2 over 9. Wow. Thank you for paying attention. Remember, you're supposed to act like I'm talking to Copeland, so you'll pay better attention.
That's where I am. What? What did you do?
All right. So, your probabilities then for each of for the red, 4 over 9, for the blue, 1/3, and for the green, 2 over 9. And so that proves out what we said a while ago. When we were looking at the picture itself, we said that the blue, or the red, had the most marbles in there, so therefore our probability would be higher. Well, 4 over 9 is almost 50%. Okay, so we're real close to having 50% of the marbles being red, so obviously you've got a better opportunity to reach your hand in, not seeing what you're reaching for, and pull out a red one. That does not mean that you're going to do that. Okay, it is just a probability that you're going to do that. Okay, so for example, when you're flipping a coin, okay, when you're flipping a coin, let's talk about this for a second because it's going to go into theoretical and experimental probability. When you're flipping a coin, say we're flipping a quarter, okay, there are 2 probabilities. The 2 probabilities are a head, and a tail. Okay, those are your 2 probabilities that you can do if you flip a quarter. Okay, obviously a quarter has 2 sides. It's got a head on one side, tail on the other side, and so therefore the probability that you're going to flip and land on heads is equal to 1/2. Okay, the probability that you're going to flip and land on tails is equal to 1/2. Now, that is a theoretical probability. Okay, it is something that should happen given the information. So this is a theoretical probability. Okay, most of the time that's what you're going to be finding is the theoretical probability. Occasionally you're going to actually try to do an experimental probability, which an experimental probability is used to try and prove a theoretical probability. Okay, so given our example of flipping the quarter and having a 1/2 or 50% probability of landing on heads or tails, what is an experimental probability that I could do to try to prove that? Do what, Copeland? Yeah. An experimental probability would be take the quarter and flip it 10 times, 10 different times, and record the results and see if the experimental probability proves the theoretical probability correct. We've done that several years. We did it last year in 7th grade. I think we did it in 6th grade as well with you guys. And you're the person that can't remember. Yeah, and I'm supposed to rely on your memory for 6th grade.
What?
You remember what? You remember what year you were in the 6th grade?
Yeah.
Okay.
2012.
You sure?
Yeah.
You sure?
2012 to 2013. Because last year is 2012, and then February is 2013 to 2014, and 2014 to 2015. No.
I'm shocked and amazed.
Why do you always look at me?
No, I was just asking.
Am I the most intelligent in the class?
Oh, whatever.
Okay, let's not go there. All right. Anyway, back to the lesson. We don't have time. We don't have time to do an experimental probability to prove whether or not you remember stuff. Hey. All right. Now, we did the experimental probability last several years, and all those times I've done it in several different classes just besides this class, and we've never proven it correct. In other words, we flipped the coin 10 times, and 6 or 7 of the times we landed on heads, or 6 or 7 times we landed on tails. It was never 5 heads, 5 tails. Okay? And so that's why I'm trying to get you to understand that probabilities are just simply an estimate or guess of something happening. Okay? The only way that it is going to happen is if there's 100% chance. For example, okay, if I get the same brown bag and I dump 18 green marbles in there, okay, and I want to know the probability that I'm going to pull out a green marble, reach in the bag and pull out a green marble, well, that's 100%. That's going to happen. It's the only option you have, okay? And so that's what a probability, the only time that a probability is for sure going to happen. Even a probability that has a 90% probability of happening still has 1/10 that it's not going to happen, or 10%. And that 10% could come true. Just like, for example, with the lottery. Okay? The lottery, to win the lottery, where you're guessing the 5 or 6 numbers, whatever it is, the probability is like 1 in 2 million. Okay? For each individual person. But somebody always wins it. Yeah, because there's so many people playing it. Okay? That would be like this. If I took 100 people and I took that brown bag that has all those marbles in it and I put 20 green ones and 1 red one. Well, if I let 1,000 people reach into the bag, grab a marble, and then put it back, probably out of those 1,000 people, somebody's going to pick the red one. Okay? But before they stuck their hand in the bag, they still had a 1 out of 21 chance of doing it. Okay? So that's why everybody goes, well, the probability is so high, but people still win. Well, yeah. Okay? If I take 1 million people and set them out in the middle of a bare land, flat land, in a thunderstorm, well, the probability of any of them getting struck by lightning may be 1 in 1 million. But there's a real good chance I got 100,000 people out there that one of them are going to get struck. Okay? So it's an individual probability. It does not apply to, that's why you see people that win the lottery where there may be 5 or 6 people win the lottery. And they didn't combine it at work, and they actually 5 or 6 different people guessed the number. Well, that's true, because when you got millions of people playing the lottery, you're going to have repeat people, giving the same numbers. There's a high probability of that. And if you keep reaching your hand into the bag, if Josh's probability is 1 out of 21 to grab that red marble out of the 21, I mean, if he reaches in there 1,000 times, then yeah, he probably is going to pull out the red one of those times. But his probability each time is still the same, 1 out of 21. Okay? So that's why the probability is so high for the lottery to win the lottery, but why people do win the lottery. Okay? So understand that probabilities are just simply that. They're not a proof. That doesn't mean it's going to happen. Doesn't mean it's not going to happen. The probability of somebody getting struck by lightning is like 1 in a million. Okay? For somebody to get struck twice by lightning is even, it's astronomical, but it still happens. All right? So understand that probabilities are just a mathematical guess or a best prediction of a certain event happening. Okay? Now, obviously, when we're talking about probabilities, the closer the fraction is to 1, the better the probability that it's going to happen. Okay, so 1/10, 2/10, 3/10, 4/10, 5/10. The closer I get to 10 over 10, the better chance I have that it's going to happen, or the better probability. All right, now, so let's look at odds in favor and odds against. Okay, when we're talking about odds, and they say it a lot, especially when they're looking at what people gamble on. They bet on games, they bet on football, baseball, they bet it. They go to Vegas and bet. That's where odds are. Okay, that's where odds are coming into play. That your odds of winning are this, your odds of winning are that. Okay, it's not really. It is a form of a probability, but the formula for each one is right there on page 308. We have odds in favor.
What is that thing?
Okay, odds in favor is the number of favorable outcomes. Okay, and here's where it's different. Number of favorable outcomes over the number of unfavorable. Okay, so a while ago when we were talking about the marbles, the odds that I'm going to pull out a blue marble up here, okay, we had 6 blue marbles, but we had 12 that were not blue. So the odds in favor of a blue marble would be 6 over 12. Instead of 6 over 18, you do 6 over 12. Okay? And that would reduce down, obviously, to 1/2. So your odds of pulling out a blue marble are 50%, basically. Okay? Your homework, you're going 6.7, 1 through 13. That's it. Okay? You can go.